Okay, honor students, this video is for you and you alone. It's your third video of the day, and it's our final video that goes with the reactions section and the chapter we're in. So this video is called Reactions-9, and it's just more review and practice over all the concepts that we've been talking about. When you do these problems, you've got to think about how to write formulas, how to balance reactions, what type of reaction is being formed, and whether or not that reaction will even happen. So there's a lot to do, there's a lot to think about. So while you're watching the video, please take notes, pause, try it on your own, and then see if it matches the answer. If you do that, you're going to find this quite easy, but if you just blow through the video, you're really going to struggle. Okay, I know I keep saying that, but the best way to do this is to do it yourself. Okay, so I want us to start with a reaction, and I'm going to give you this reaction, NaOH, which is sodium hydroxide. Sodium hydroxide is an aqueous solution, and we're going to combine it with iron 3 nitrate. Okay? All right. Now, we have to decide if this reaction is going to occur. Based on the 5 types of reactions that you know about, synthesis, decomposition, single replacement, double replacement, or combustion, this looks like it would land up being a double replacement reaction. I can't see it being a synthesis. There's too many things going on for a double replacement. Nothing's singing all by myself, so it's not a single replacement, and there's no oxygen for burning, so it's not a combustion. So we're left with a double replacement reaction. So remember, the first thing you're going to do with a double replacement reaction is play wife swap and swap these two guys. So I'm going to pause the video, and I want you to swap those two and finish the reaction. I'm not pausing the video. You pause the video, finish the reaction, and then write the formulas correctly, and then check and see. Okay? All right, so if you wrote the reaction, you should have written NaNO3 plus iron hydroxide. Now let's talk about this. First of all, you could have written iron hydroxide first and then NaNO3. That doesn't matter. 1 plus 2 equals 2 plus 1, so that's not a big deal. The second thing that you need to do is make sure that you wrote your formulas correctly. So let's see. Let's see if I wrote this one correctly. Na has a charge of +1. Couldn't help myself. Na has a charge of +1. NO3 has a charge of -1. So yep, I wrote that one correctly. Good job, Mrs. A. And now FeOH3. Well, stink. How do I know what the charge is on Fe? Fe is a transition element. Well, don't despair. If I go back and I look over here, NO3 is -1, and there's 3 of them. So the total charge here is -3. That means the total charge here has to be +3. So this is iron 3 nitrate. So if it was iron 3 when you put it in, it's still going to be iron 3. It's not going to magically transform. So this has to have a +3 charge. And O negative, it's hydroxide. OH is negative. There's 3 of them. -1, -1, -1. Oh, -3, +3. Oh, I'm so smart. I just wrote this reaction correctly. So proud of myself right now. Okay. The next thing, we have to see if one of the 3 rules applies for this double. We're not in the lab, so we can't test it, okay? So we have to see if this reaction actually happens. Now remember, for a double replacement reaction to happen, one of 3 things has to occur. Either a precipitate has to form, or a gas has to form, or a molecular compound has to form. Often you'll see it as water. Okay, so now we're going to go back to the PowerPoint slide 29, and we're going to look around, and when we look, we see that for most hydroxides, except for sodium hydroxide, they're listed as insoluble. Insoluble means does not dissolve. And if something doesn't dissolve, then it stays a solid or becomes a solid. So we have a solid. And then we look at this one. Most nitrates are soluble, if you look at your chart. And remember, if and when we have a test, you'll be allowed to use that chart. Soluble means it does dissolve. That means this one is going to be AQ for aqueous. Okay, and this one was aqueous. We mixed two aqueous solutions together. Now, if you notice in the prior video that you watched with the pretty yellow precipitate, those were two aqueous solutions, and then you had your yellow precipitate, and then you had your aqueous solution. Okay? All right, so there is really a lot to think about, but if you're methodical and slow and don't try and rush this, you're really going to become good at it. Okay, let's try another one. Let's try see if potassium hydroxide, KOH, aqueous, will react with hydrogen phosphate or phosphoric acid. Wait, how did I do that? Quick acid naming reminder. Hydrogen phosphate. How do I know it's an acid? It has an H. Okay, so now hydrogen phosphate has the 8 ending. And remember our little rhyme? She ate it and got bronchitis. This has an 8 ending from phosphate, so it's going to be phosphoric acid. So many things to remember, hey? But that's okay, we got this. We're not scared and we're smart enough, so life is good. All right, now this, of course, it's two compounds, so by now you're probably getting used to the fact that when you see two compounds, you're gonna make a double replacement reaction. So we're gonna trade places. All right. Now, you're going to put that hydrogen in front of the OH. Well, what happens if you put a hydrogen in front of OH? You have HOH. And what is HOH, my friends? Dihydrogen monoxide. Oh, you mean water? Yes, HOH is water, but I'm going to leave it as HOH because it's going to make my balancing life easier in a moment. And then, what's left? Now K is going to be bonded to phosphate. Well, phosphate is PO4 minus because you've memorized that. K is +1. So pause the video and write that formula correctly. Okay, so you would need 3 Ks, and it's K3PO4. All right, now we have just satisfied the second thing, or one of the three things, for a double replacement reaction to occur. We made water, or a molecular compound. So this reaction, check, will occur. Obviously, though, it is not balanced. So we're almost done. I'm going to erase all this extraneous stuff. And I want you to pause the video and balance it on your own. Okay, hopefully you pause the video and balance it on your own. And so you should have put a 3 there and a 3 here. See how nice it is when you write water as HOH? Because now you can balance the hydroxides. There's 3 of them. And you can balance the H's. There's 3 of them. Much less complicated than if you were trying to balance H2O. Then you'd be counting up H's and maybe feeling a little bit overwhelmed and sad. But you don't need to be overwhelmed and sad. Just change water from H2O to HOH. So this is a great example of a reaction that will occur because it makes a molecule, and in this case the molecule is water. So we're almost done. let's fix this. Let's put L for liquid and AQ for aqueous. All right, good job. All right, let's try another one. Let's try another one. How about this one? I'm going to take barium nitrate, and of course it's an aqueous solution. And I'm going to mix it with phosphoric acid, H3PO4. And it's only going to happen if a water forms, a gas forms, or a precipitate forms. Okay, so now you're going to do everything on your own. You're going to pause the video. You're going to play wife swap. You're going to look at the solubility table and see if anything is insoluble. You're going to label what's insoluble and tell me if the reaction is going to occur. And then if it does, you're going to write the formulas and balance it. So I want you to pause the video. It's going to take you a couple minutes. Pause the video and do that. Okay, hopefully you paused the video and you did that. If you paused the video and did that, you should land up with this. Whoa, sorry. Ba3 PO4 2 barium phosphate plus hydrogen nitrate. She ate ick and got bronchitis. So nitrate, oh, this is nitric acid. Huh, I knew that. You did too. It's in your brain, I promise you. Okay, so that's nitric acid. Now, whoa, this thing was a nightmare to make the right formula, huh? Why did we have to do all of that? Well, remember, phosphate is -3 and barium is +2. So that means we need, oh, sorry, this thing is wonking around. +2, +2, -3. So I need 2 sets of phosphates and 3 bariums to make +6 -6. Okay, and this is not balanced. And when you balance it, I'm going to wait and let you pause and fix your formulas if they were wrong, and then try balance it on your own. Okay, hopefully you balanced it, and if you balanced it, it should have a 3, a 2, and a 6. Okay, so we are now finished with chapter 11. I want you guys to pat yourselves on the back. You now know how to balance reactions. You know how to identify types of reactions. You know how to predict if a reaction will occur. And you know how to determine if something's a solid molecular compound. And you have tables to let you know that. Okay, congratulations. And I'll put up your homework assignment, and hopefully you'll find it very easy after watching this video. Email me if you have questions. Have a good day. Bye.